Welcome to Biology 101. Today we'll be talking about protostomes and deuterostomes. Warning, this video may be highly entertaining and you may want to roll on the floor laughing, but please wait till the end of the video. When it's over, feel free to ask questions or stand up in a standing ovation and clap very loudly. Of course, not too loudly because we're next to a classroom. So please enjoy. Protostome is Greek for mouth first, in which the mouth arises from the blastopore and the anus forms later. Some protostomes are arrowworms, flatworms, annelids, mollusks, arthropods, and nematodes. Deuterostome is Greek for mouth second, in which the blastopore forms the anus and the mouth forms later. Some deuterostomes are echinoderms, hemichordates, urochordates, and vertebrates. If you couldn't tell from the lack of movement, that starfish was a video. In both developments, a zygote develops into a hollow ball of cells called a blastula. In deuterostomes, the early divisions occur parallel or perpendicular to the polar axis, called radial cleavage. Most display intermediate cleavage, in which the developmental fate of the cells in the developing embryo are not determined by the identity of the parent cell. If the first four cells are separated, each cell is capable of forming a complete small larva, and if a cell is removed, other cells will compensate. Protostome is spiral cleavage rather than radial. The coelom forms by splitting rather than outpocketing, which forms a mosaic embryo, which is an individual with two or more populations of cells with different genotypes from a single fertilized egg, rather than a regulative embryo. Some protostomes only have two germ layers, but most have three like deuterostomes. In protostomes, the germ layers don't touch each other. Deuterostomes have three germ layers that come into contact. This allows complex development of tissues and organs through a process called organogenesis. The coelom branch subdivides into protostome or deuterostome animals. During protostome development, the final outcome of the cell cannot be altered. If one cell is changed, the embryo will not develop normally. Cells can be altered in the developmental stage of deuterostomes. Another difference is in the cell alignment at the 8-cell stage. 4 protostome cells are offset, giving them a spiral appearance. Deuterostome cells are aligned at the 8-cell stage. Blastula forms in both types of development. However, changes occur in the location of the mesoderm. Protostome mesoderm is located near the gut, while the deuterostome mesoderm forms two pouches opposite the gut. As the embryo continues to develop, the mesoderm of the protostome splits and forms the coelom. Deuterostome coelom forms from pouches of mesoderm that separate from the gut. The blastopore, an opening in gastrula, forms the mouth in protostomes and the anus in deuterostomes. If you have a book, you can turn to page 457 and look at this cladogram with me as I talk about the origins. The majority of animals that are more complex than the jellyfish and other cnidarians are split into two groups, the protostomes and the deuterostomes. Chordates, which are all the vertebrates, are deuterostomes, but scientists find it very likely that 550 million years ago, Kimberella was a member of the protozomes. If that's true, then that means that the protostome and deuterostome lineages must have split sometime before the Kimberella appeared, which is at least 558 million years ago. And then that would be the start of the Cambrian 541 million years ago. To summarize and make sure you got all the major points, the protostome has a blastopore that develops into a mouth, spiral determinate cleavage, and the formation of the coelom by splitting the mesoderm. This group includes annelids, mollusks, and arthropods. Deuterostomes have a blastopore that develop into an anus, indeterminate cleavage, radial cleavage patterns during early developments, and this includes echinoderms and the chordates. Their coelom also forms by the outpocketing of the mesoderm. Both have distinct evolutionary lines to the coelomates, complex skeletons that allow them to be highly mobile, bilateral symmetry, and are tripoblastic. I hope you enjoyed this highly informative segment on deuterostomes and protostomes. If you have any questions because you're confused or missed something, or just, want to chat, Feel free to ask after the standing ovation. I promise I won't laugh at your question because this information is a lot.